Hello and welcome to another Bitesize Bioinformatics. I am Stephen Wingett and I work in the Baber Bioinformatics group. And today I'm going to be talking to you about introducing version control using Git and GitHub. Now, owing to internet restrictions and the broadband of my current internet service provider at the moment, I'm not going to be giving a live Zoom call. I've pre-recorded this talk and we're going to upload it and play it as live. And then at the end, hopefully I'll be able to answer any questions you may have about the talk. However, I should be getting a new internet service soon, so hopefully the forthcoming talks will be a bit more like normal. Okay, just a couple of notes on Zoom. If you move your the mouse pointer to the bottom of the screen, a little bar should pop up, and it's here if you have any messages you want to share with me or ask any questions. If you move the little pointer down to here and click on chats, you can ask me any questions. Also, if you want to attract my attention, you can also sort of virtually raise your hand via the Zoom call as well in this way. And I'll try and get back to you at the end of the talk and discuss any of the points with you may have. Okay, so that's the basic introduction out of the way. Let's get on with the talk. So who needs version control? Who am I aiming this talk at? Well, essentially anyone who writes code. Okay, so maybe I am exaggerating a little bit. Maybe if you write a script once every 6 months or very rarely, then maybe you don't need version control. But for anybody who's routinely writing scripts or scripts will form an integral part of their research and analysis, I highly recommend getting to grips with version control. And certainly, if you're involved in some sort of pipeline development or software development, you absolutely should be using some sort of version control routinely to manage your software updates. It's not necessarily just people who write code who can benefit from version control. People who write documents in the text format Markdown or LaTeX could also benefit from managing their documents using a version control system. So, what exactly is version control and why do we need it? Well, if you just look at the slide, I'm trying to illustrate some of the problems we encounter when we have any sort of sizable project. So if you look at the left-hand side, we have version 1 of some sort of software project. We have 3 files, file A, file B, and file C. So as time goes on, we decide to make some modifications to this project. And what we firstly do is we modify file A, so that's why we have the little asterisk next to the A. And we've also decided to delete file B. So we now maybe have 2 files, file A and file C, which work together and don't require file B. So that's fine, we now have a new project which works correctly. But we may, for a variety of reasons, might not want to completely lose the first version that we had. We may have used, for example, version 1 on some sort of an analysis that we've done previously, and we may want to retrieve that version if and when, as and when is required. So we now have a current version of the project, which is our best version, which we want to use going forwards, and then we have a previous version that we may want to retrieve. Version control essentially takes sort of snapshots as and when required by the user and stores all the different versions of your software project. So you could use the version control to store version 1 of your software project, and you can also then subsequently use it to store version 2. It records all the files that have been modified, all the files that have been deleted. We then move on to version 3 in a similar fashion. Again, we've modified file A further. We've now gone on to modify file C, and we've also added file E. And we have a third version now of the software package, which is quite different from the second version. But with our version control system, we can record these changes, have a new version, version 3. It will record the new files that have been added, make a note of the files that have been modified, and allow you to go back to the previous version as and when is necessary. From a user's point of view, this is essentially what a version control system enables you to do. It allows you to record all the changes that were made to a project throughout its lifetime, and retrieve any previous versions as required. The descriptions I gave in the previous slide are not the only reasons why I would recommend using version control. Firstly, it's an excellent way to keep track of how and why scripts were modified. So, for example, you can easily see how one file differs in its contents between versions. The user can also make notes on why they made the changes to their code, whether that be to correct a bug or add some sort of new functionality, or whether it was to simply refactor their code. That way you have an audit of how your code developed throughout its lifetime. Also, version control lends itself very well to backup capabilities. Backing up any sizable project is essential. Under no circumstances do you want to find that you have lost all your work due to some sort of hardware failure or similar. There are many websites now available that allow you to upload scripts which are kept under version control. As part of these websites' functionality is the ability to provide documentation describing what a project is for and how it should be used, etc. At the moment, this is one of the best ways to write and record documentation for any given project. Also, if you do use one of these websites, which I'll be talking about later, this provides an excellent way to collaborate with other people. That is, multiple people or teams can work on the same project to achieve shared goals. Also, if you want to make your code publicly available, these websites are an excellent way to share your code, and it has become pretty much the de facto standard way of sharing any software project you may have. So the version control I'm going to be talking about in this talk, Git, uses something called distributed version control. So let me just spend a little bit of time explaining what that is. On the screen here, you'll see a representation of your computer. That is, you've got a software project that you want to bring under version control. That is your working copy. These are all the files of your software project. So what you do is you then bring them under version control. So the idea is that you make a version control repository, and it is into here that you commit the files from your working copy. So when you decide you want to bring your working copy under version control, they essentially become committed to the repository. You can then go on to make changes to your working copy just as you would normally. That is, you'll just edit the files, save them as before. When you feel you have made sufficient changes to your working copy, you will then decide to commit them once more to your repository. If you wanted to go back to a previous version of your project, you could then retrieve that version from the repository and update your working copy. So this is all well and good. You have a working copy on your computer, and you are regularly making changes to that working copy and committing them to your local repository. However, there is a problem to this in that this working copy and repository are only kept on one computer, and therefore they're vulnerable to any sort of problems if that machine no longer became available, and it may not be accessible from outside. So for this reason, we would then want to put this repository on a main server, which is external from computer 1. So what we can do now is we have a new way of working where we can make changes to our working copy and then commit them to our repository as before. Then we can make changes to the external repository by pushing the local repository on computer 1 to the main server. By doing this, we now have a local repository which records the changes of our working copy, and we also have a remote repository on a main server which is keeping track of our working copy. But this is not the end of the story. We may, for example, want to work on our project on a different computer. To do this, we would pull the repository from the main server onto our new computer, that is computer 2 here. After we've done that, we can then create a working copy of our project on computer 2 by extracting the files from our repository. And likewise, we can do this on a third computer. By doing this, we can now seamlessly work on one project on 3 different computers. So let's suppose computer 3 is a desktop in our home, whereas computer 1 is a desktop at work. So we're working from home currently, and we decide to pull down the repository from the main server onto computer 3. And then from this we create a working copy. We then work on our working copy, make the changes we need, commit it to the repository on computer 3, and then we push this to the main server. Now all the changes we've made at home are on our main server. The next day we go into work, and then we pull down the repository from the main server onto computer 1. We now have the up-to-date repository on computer 1, and then from this repository we update our working copy. We can now work on the latest version of our project on our computer at work. Using this technique of committing and updating and pushing and pulling, we can work on the same project seamlessly on any number of computers we so desire. Another key advantage of this distributed version control is that the repository is kept in numerous locations. So, for example, if we were to lose computer 3, we would be able to retrieve the whole repository from either the main server, computer 2, or computer 1. Just as an aside, this distributed version control approach is therefore in many ways more robust and secure than a centralized version control system, such as Subversion, where the repository is typically kept in one central location. So currently, the most widely used version control system is something called Git. Git is a distributed version control system and therefore is more stable. The software was created originally by Linus Torvalds, and that was back in 2005. Now, for those of you who don't know, Linus is the person who was responsible for developing the original Linux kernel. He started work on Git initially as a version control system for Linux development. This was after a previous version control system, which wasn't produced by him, suddenly started charging for its services. Linus Torvalds is well known for espousing views that software should be freely available, and as you may expect, Git is free and open source, and is distributed under the GNU General Public License version 2. There are several explanations for why he named the software Git, and if you're at a loose end sometime, it can be quite amusing to just have a look online and see what those possible reasons might be. So hopefully I've convinced you by now that Git is worth using on your own projects. And if that's the case, you'll be wondering how to get hold of it. Well, Git has a homepage, which is printed here. Let's see, git-scm.com. And this really should be your first port of call for anything to do with Git. Not only can you download Git from here, it also has extensive documentation on how to use Git, and there are also other useful links on this website, such as those that put you in contact with the rest of the software community that use Git. So let's have a quick look at this webpage. So this is the current Git homepage. You can see the Git logo here. There's a little, and there are a series of links about Git on here. There's a little bit of general information about Git, but importantly, you can download the Git software from here. So if you click on here, it will give you a list of options on how to download the software. Got information on the latest version of Git that's available, which currently is 2.26.2. And then there are a series of download options. The web page is automatically detected that I've got a Mac. So here is the download option for a Mac. And obviously this may be different if you have a different system. Alternatively, if you don't want to download directly from this link, you can download the specific version of Git that you require. So for the Mac operating system, it's here. For Windows, it's here. And then for Linux or Unix, it's here. I'm not going to go into too much detail about the whole installation process, but it's pretty much what you'll have become familiar with already with your computer. So for a Mac, there's a homebrew options, or you can use a binary installer. Likewise for Windows, there will be 32-bit Git setups or 64-bit Git versions, and if you click on those, you will start the download of the executable file. For most modern computing systems, it will be a 64-bit version that you require. And then if we go to the Linux version, you'll see a series of commands which can be entered into the command line to install the software. So it should be anybody who's used to using computers and installing software, it should be fairly straightforward on how to install the software. If you are having any difficulties installing Git, then if you go to the community section here, there will be links here about how to get help and maybe online support, and assistance from other people who use Git on how to install the software. But it should be fairly straightforward. In addition to that, on the web page there is the official documentation for Git. So if you click here, you go to the reference manual, you'll see a list of all the commands and all the concepts in Git. And if you just click on these, you'll get, if you click on these links, you'll get detailed descriptions of how to use them and all the various options associated with each command and so on. So there's exhaustive documentation there. If maybe you're looking for more of a instruction manual, there is a detailed book, the entire ProGit book, which you can click on, and you'll get a web version here of the book, which gives you an introduction to the concepts and how to use Git, or you can download a PDF version and other formats by clicking on the links here. So that's a nice introduction as well. Well, more than an introduction, it takes you from an introduction to an advanced user of Git. There are also useful links here to cheat sheets. So cheat sheets provide upfront all the sort of key concepts and commands that you're likely to need while using Git in a very condensed format, usually just the side of A4, which you can refer to again and again to help you which you can refer to again and again just as a sort of aid memoir for entering Git commands. So that's very useful as well. So on the home page, the Git home page, they're very useful. It should be your first port of call to anything associated with Git. There's general information, links to download the software, extensive documentation, and community links as well. So now I'm going to talk about starting from scratch. Suppose you have a project of some kind that you want to commit to a Git repository. How would you go about that? What do you need to do? So for this example, we're going to imagine it's the first time you've ever used Git. So I'm going to show you how to configure Git, and then I'm going to talk about adding your project to a Git repository. So for this example, I'm going to use Ubuntu. Things should be very similar whatever the operating system, and the syntax for Git should be the same. So what you can see is the command line. You will see a similar view if you open up the terminal on a Mac operating system, and it's also quite similar to the MS-DOS prompt. I'll also talk about later on a little bit about using a GUI to interact with Git. That's a graphical user interface. This is a more user-friendly format for those who are not particularly conversant with the command line. So I've just made the font a little bit bigger there. So you'll know if you've got Git on your system by just typing Git in the command line and pressing enter. And here you see it's not been found and it's not been configured. So I will quickly install this in Ubuntu, and it gives you advice on how to do that as well. So I'll just pause the video just so you skip all this downloading and installing the software. So now it's installed. If you type in Git as before and press enter, you will see this page which gives you help on how to use Git. And there you see many of the key commands that you would use while using Git. Also, if you type in git --version, you'll see the version of Git that has been installed. So if we have a look into my current working directory, you'll see there is a folder called My Project, and this contains all the files I want to put under version control. So if you do ls my project, you can see them all here. They're actually, in reality, just very simple text files containing a line of text. So if we just had a look at one of them, for example, my project file A, we'll just see it's a line of text. This is file A, is all it says. And although it's text, it's not code, the similar sort of rules apply. As essentially, scripts are just text files, so we can just treat them as code or some sort of document that we want to keep under version control. So we want to commit my project to a Git repository. The first thing we need to do, because we've just installed Git, is configure it. You should only need to do this once. There are a series of configuration options for Git, and you can list these with the command git config list. And you'll see that at the moment there are currently no configuration options that have already been specified. We are now going to tell Git our name and email address for the purposes of the configuration. So to do this, we type in git config. It's a global option, and user.name, which is my name, is Stephen Wingate. And now we need to enter my email details to set up the configuration. And to do this, it's a similar command. Instead, it's git config global, and then it's user.email, and then I type in my email address, which is stephen.wingate@abraham.ac.uk. And now if we do git config list, you'll see that these have been configured. Okay, so now we want to add my project and make that become under Git version control, and we just type in the command git init, which is initialization, my project, and then press enter. And now the Git, and now my project will be under version control. And you can see that is the case. If you go into Git my project and you do ls, you'll see the files which are there. But if you do ls-a, which will list the hidden files as well, you'll see there's a .git hidden file, which is a way of telling you that this is under version control. So just to recap a little bit here now, if you remember when we talked about distributed version control, you remember there was a process of committing files from a working copy into your Git repository, and then there was the reverse process of updating your working copy from the files found in your Git repository. So this is just zooming in on that process, looking at one working copy and one repository on your local machine. So that's fine, and that's how it works. But this is a little bit of an oversimplification for Git. For in between these two processes is something called the staging area. So in our working copy, we have our files. These may be new files, or they may be files that we've edited. And then we want to make the corresponding changes to our Git repository. So let's suppose we have a new file we want to add to our repository. The first thing we want to do is add it to something called the staging area. This is a sort of in-between step between committing to the repository and just having a file in your working copy. This area is essentially identifying all the files that should be updated in the repository following the commit process. So let's suppose we have a new file. The first thing we need to do is add it to the staging area. Once it's been added, it's ready to be committed to the repository. Just to make you aware, the reverse process, that is, updating the working copy from the repository, bypasses the staging area, and this is a one single step process. I'm inside the working copy directory at the moment, and we see the three files, file A, file B, and file C. And while these files are in a folder which are under version control, this does not mean that these files are yet under version control. To illustrate this point, if I type in git status, you'll see a series of messages, but importantly you'll see untracked files, file A, file B, and file C. These files are untracked, which means they are not under version control. There are a number of ways to put them under version control using Git, and I'll go through one of them now. So the first thing we need to do is to add the files to the staging area. We do this with the command add. So git add, and then the file names we wish to add to the staging area, which is file A.txt, file B.txt, and file C.txt. Now, if we type in git status once more, we can see we have now new files. These are files which have not yet been committed to the repository but are sitting in the staging area. So how do we commit the files in the staging area to the Git repository? Well, it's a simple command, and as you might expect, it's git commit. When you choose to commit files to the repository, you should leave a message which will help you in the future. This message should tell you why you are committing these files. For example, in this example, we are initializing the Git repository. We're setting it up. So I denote I am adding a message by -m, and then I type in my message in speech marks. And my message will be initial setup of repository. Like so. We press enter, and we have now added the files in the staging area to our Git repository. If we type in git status once more, we'll see there is nothing to commit and there are no files in the staging area. That is essentially our Git repository is completely in sync with our working directory. In addition to this, if you type in git log, you will be provided with a list of all the commits that you've made to your repository. In this case, there is one. It will show you who committed the files to the repository. This uses the configuration information that we provided earlier. It also gives the date and time the files were committed, and it also gives the message which you provided. That is here, initial setup of repository. So we've now created a Git repository from scratch and committed our three files. Okay, so we've now made our Git repository and added files. Let's do some other things. One of the most common things you need to do when working with Git is editing a file and committing this to a repository. Also, at some point, you may need to remove files from your Git repository. How would you go about doing this? So let's talk about editing files. Here we can see our 3 files in our Git repository. So let's edit file A. We'll do this with the text editor Nano. So here we can see file A. So let's now edit this file. Let's make this uppercase, like so. We save this and go back. So all the files are here as before, but if we look inside file A with the cat command, we see it has been edited. If we type in git status now, git status will tell us that file A has been modified. This means that file A in my working directory is different from that in the Git repository. Git has a useful feature where you can compare the contents of a file in your working directory with that in the current staging area. The command to do that is git diff. So if we type in git diff and then file.a.txt, we can see that the file has been modified. At the bottom of this, you can see the line that has been edited. In red, you'll see what has been removed, and in green, you'll see what has been added. If I run the same command on the other files, you'll see there are no changes. Okay, so we've modified file.a.txt, but as you can see, it's not been added to this staging area. Just to tidy this up a little bit, if we do git status, we can see that file.a.txt has been modified, but it's not actually been staged. To add it to the staging area, we do git add again. So git add file.a.txt. Now if we do git status, and we can now see the changes to be committed. And now in green, we have file.a.txt. So it's now moved from not staged to staged. We're now ready to go ahead and commit it. If we don't want to do this straight away, we can use the reset command to put it back out of the staging area. Now if we do git status, we'll see that file A has moved back to where it was before. But we do want to go ahead and commit it, so let's add it once again. Let's look at the status. We'll see it's ready to be committed and it's in the staging area. And now we commit it with git commit. We provide a message. So we could say modified file for demo purposes, and put in any message here that's useful to you and will make sense to you in the future, and that may be several years in the future. And if you're collaborating with other people, leave messages that will make sense to them too. You can't be too detailed with the messages you leave. The more information, the more it will help you and other people in the future. So let's do git commit. And now if we do git status, we'll see there's nothing to commit. And if we did the git diff now on our file A, we'll see there are no differences between this file and the Git file, and we'll see there are no differences between this file and the file in the Git repository. And now if we do git log once more, we'll see our 2 messages. We have our initial setup of the repository, And we also have the modification of file A. Now let's suppose we want to remove one of our files. Let's suppose we want to remove file C. To do this, we do git rm filec.txt, and now if we do git status, if I type it in correctly, okay, now I type it correctly, and we will see that file C has been deleted. You'll notice it's also been deleted from our working directory. You'll also see from the text message that these changes will be committed. That is, when we next type in git commit, this file will be deleted from our repository. So let's go on and commit as before and leave a nice message and leave a clear message. We'll see this change has now been committed. Git status, we're up to date. We'll see we have 2 files in our working directory. And if we do git log once more, you'll see the message that we've removed file C. Just as a brief aside, I wanted to talk about how you would view the contents of files from a previous version you've already committed to your repository. So we have currently these 2 files after we deleted file C. Now suppose we want to view file C once again, and that was how file C was to start with. How would we do this? Well, this is one way. There are other ways, and there are various reasons why you might want to choose a different way of doing it over this way. But just for this brief introduction to Git, I will just go over this way. So to view our previous commits, we run the git log command, and we see this. Now what you should notice here is, in addition to all the messages and the date and the time, etc. I've just discussed before, each commit has its own unique ID. So you can see that here, this one begins 7.9, this one begins 9.9, and so on. What you can do to view a specific commit is you can do the git checkout command and then copy in the name of the unique ID of the specific commit. So let's suppose we want to look at the initial setup of the repository. If we copy this ID, in fact you can just copy the starting few characters of the ID. That should be enough to uniquely identify it, but I've copied the whole thing here. If you do git checkout and then paste in that ID, what you will now see is that the original files are now there, and we could have a look at all of these files, by the contents of all of these files, by doing cat star and then the contents of file C is that. So we can see the original versions of the files. So this is how you can view any previous commit that you've made to your Git repository. So how do you get back? Well, that's quite straightforward as well. To get back to where you were, and you will need to do this because at the moment you're in something called a detached head state. So I don't want to discuss that in detail for the purposes of this introduction, but what you'll need to do to get back to where you were before is to run git checkout again, and then master. And master is the name of the main branch in Git. And this will take you back to where you were before. And if you have a look, we now only have 2 files once again. I will introduce the concept of branches later in the talk, but by default, when you start a Git project, the first branch you create is something called master. and that is what you have checked out here. So that's just a brief introduction of how you can view previous commits and then go back again to where you started off. So now I'm going to discuss GitHub. I'm going to explain what it is and why it's useful. To give some context, I'm showing once again the schema that shows how Git works as a distributed version control. And what you can see at the top of the screen is the main server. This main server hosts the repository from which all the other repositories either push or pull commits. So one place where you can host this main server is GitHub. And it is with GitHub that your local repositories will communicate. So GitHub is found at the web address www.github.com. And in the next few minutes, I'm going to discuss how you would add one of your local repositories to GitHub. I'm going to show you how when you make changes on your local repository, you can then sync this with GitHub. I'm going to then talk about how you can browse the GitHub website to find repositories that you might be interested in, and how you would move these repositories to your local system. I'm then going to just show you a nice feature of GitHub which allows you to make documentation for your project. So as I mentioned before, the homepage of GitHub is github.com. And on the homepage you will see a login link here for you to log into GitHub. And you will also see an option for you to sign up, which is if you don't have a GitHub account, which is what you'll have to do. So it's nothing sort of out of the ordinary. If you just click here, and then you can create a new account. And once you've done that, you're ready to go. You can now start linking your GitHub repository that you've created locally and push it to the remote site on GitHub. So I'm now going to just talk you through how to do this. Okay, so the GitHub repository that we just created, we now want to upload to the GitHub website. So how do we go about doing this? The first thing we need to do is go to GitHub and create a repository on that site. And to here, we will upload our local repository. So if we go to GitHub, and this is what I see on my GitHub homepage. So when you get to the GitHub website, you'll see something like this. Maybe it will be a little bit different for you as you have no GitHub repositories already. But that doesn't matter. All you need to do now to create a repository is click on the New button. And then there is a simple process involved in making a new repository. So the owner will be you, so that will be your username. And now you need to specify the name of the repository. And I'm going to use the same name I used for the folder on my local copy. So I'm going to call it my project. Having done this, you'll be asked to describe the project. So it's always good to provide a nice little description. It helps you and possibly other people understand what your project is about. Now, you have a choice here whether you want to make it public or private. I actually have this choice because I've registered with GitHub for an academic account. If you don't have a choice to make it private and you want to, and you meet GitHub's requirements, you can, if you work in an academic institution, you can click on there to make your repository private. Else you'll need to just look into other options. But yeah, so I've clicked it as public so anyone can see it. And I'm not going to do anything here. So there are options in GitHub when you create a new repository. You can have an automatic README file, or you can have a type of license already there in the repository. I'm not going to do that because I'm already going to upload from my local repository. So everything I need has already been created. So I'm going to click Create Repository. and the repository has been made. You can see here it's called Stephen Wingate My Project. So now what I need to do is to push my local repository to the to GitHub, and GitHub very kindly provides you with instructions on how to do this. So if I go into my local Git repository and run these commands, then it should be pushed to GitHub. Also, it's worth checking at this point that everything is up to date before you push. And yes, it is. I've got nothing to commit, so I'll now implement the commands that were printed on GitHub. So this git remote command configures your Git repository, so it knows the location of the main remote server that we discussed when we talked about distributed version control. This is the GitHub link that you can see here, and when we run this command, well, when you press enter you won't see anything immediately that's happened, but if you do git config list like we did before, oops, if I can type correctly, you will see this. So now when we look at the configuration, we not only see our username and our email, we also see, among other things, the location to where the Git repository should be pushed to and pulled from. So now we need to push to that for the first time. And what we enter is git push -u origin master. And when you do this, it will ask for your username and your password. So that should have now worked. And if we go back to our GitHub repository, and if we just click on my project, we can see now that the two files have been added to our remote repository, and we can see here file A and file B. And if we click on them, we can see the contents of the file, like so. You also get information on when the files were added. So this is not when they were added to the remote repository just now, this is when they were committed to your local repository, which here was actually several hours ago. And you can see a history of your commits if you click here. So all the changes that we made, all the different commits we made to our repository on our local machine are all recorded here. And that's because we've got the full Git repository. Everything that we've done to this, all the files, all the different versions, are all stored now on our remote server and backed up securely. So we now have our Git repository, and we've put it on GitHub as well. So now how do we work with the two? How do we work with our local repository and then synchronize that with what's on GitHub? Well, let's just work through a little example here. Let's suppose I am going to add a new file to my Git repository. So we'll call this file D. So there's a simple Unix command to create a file, and it's called touch. And we make file d.txt. And now if you see, it's now available in our working copy. And if we do git status once more, you'll see this is now an untracked file. So we'll do git add file D, and then if we do git status once more, you'll see that this is now in the staging area and it's ready to be committed. So we now go ahead and commit this, git commit, and we give a message for that. Just a nice useful message that explains what it is. If we do git status now, you'll see everything is up to date, and that's fine. But you'll also see the message there that says your branch is ahead of origin master by one commit. So what does this git status message mean? Well, it refers to branch again, branch master. I will talk a little bit about branches later on, but essentially it's telling us that this branch, the local repository I'm working on, is ahead of the origin master by one commit. Essentially what that means is this commit that I've just added means that my local repository is one commit ahead of my remote repository, that is the repository on GitHub. So the two are not in sync, and this local repository now has one additional commit. So how do we synchronize the two? So let's just check that by going back to GitHub, and if we just go to my project, you'll see that there's still two files there. There's not the extra third file D. So what we need to do is we need to push the commit from my local repository to the remote repository. And that really is quite a straightforward command. It is git push. And this will ask for my username and password once again. And now you'll see that essentially the push has been completed. And if we go to our remote repository and click refresh, you'll see that file D is now there, and it was added just 3 minutes ago. So we've now looked at how to push changes committed to your local repository to the external GitHub repository. So how would you perform the reciprocal operation? So that is, say there are changes on the remote repository, how would you get them onto your local repository? So to illustrate this point, we are going to just create a new file on GitHub. We'll call it file e.txt, and we'll just leave it empty. We'll commit it straight away. GitHub's quite useful in that it tries to intelligently work out what the message should be. So create file e.txt, that's fine, little message for our purposes. So we'll commit the new file, and you'll see it's been created here. But if we go back to our local repository and just do ls, you'll see it's not there. So what we need to do is we need to make our local repository talk to the remote repository on GitHub and pull down the new information. And we do this with the command git pull. So this is essentially the opposite of git push. Instead of pushing the repository, our local repository to the remote repository, so we're now pulling down the latest version of the remote repository to our local repository. And there we do, and we can see that one file has changed in the information text that we have, and if we do ls, we now have file e. So essentially what I've done is I've showed you now how to link your local repository with GitHub and how to push the latest version of your local repository to GitHub and pull down the latest version from GitHub onto your local repository. I would advise, if you're working on multiple machines, for example, if you'll get the same GitHub repository on maybe a laptop and maybe a computer at work, and you're always working on these, whenever you start working, do a git pull. That way you can be sure that you'll be working on the latest version of the repository. Likewise, when you finish a day's work, and if you expect not to be then working again on the same repository next time you work on this project. So for example, you finish work, you finish working on the repository, you then go home and want to work on it on your home computer. Make sure before you've done this that you've pushed your changes to the remote repository. And then when you start working from home, pull it down. This way you can always be sure you're working on the latest version. If you don't do this, there are a possibility that you may have conflicting versions of the same files. This is by no means a disaster, but it does mean that you will have to resolve these conflicts at some point. So it's often easier to avoid this problem by making regular commits and pushing and pulling to and from your remote repository regularly. Suppose we do want to add this repository onto a different machine. How would we go about doing that? Well, what we need to do is we need to do something called clone the repository. So if you click on this button here on GitHub, you will have an option to download the files directly, or you can clone the full repository. So if you just copy this, you can click the button here to copy it, or highlight it and copy. But all you need to do is copy this link, and then here in your, so this is my different computer, and I want to get the repository onto here. So you see I'm working in an empty folder. If I type in git clone, that will clone the repository, and then the full link of the repository, which is this. If I type in git clone, it will now fetch this repository from GitHub. If I do ls, you can see my project, which is the folder where it's kept. If we go into here, do ls, we can see all the files. And if we do git log, we can see the full history of the project, etc. So this idea of being able to go to GitHub and then cloning the repository from there onto your local machine is very important and very useful. So for example, if we go to the Bioinformatics webpage and we look at SeqMonk, which is one of our very well used tools, which is a genome browser and analysis tool. If we wanted to download this, we could go here and we can download the files directly. Or we could, if we wanted, look at the source code, which is hosted on GitHub. So if you just click on this link, you will be redirected to GitHub. So this page is very useful. Here are stored all the individual releases of a piece of software. So if you're involved in software development and you want to have defined versioned releases for your software, you can do this in GitHub, and then you just need to tag these releases in your GitHub repository. I'm not going to go into this for the purposes of this talk, but it's a way to make particular versions of software available. But if you go to the SeqMonk homepage in GitHub, what you'll see here is this option to clone, and if you copy and paste this, you could then clone the GitHub repository for SeqMonk onto your local machine. And likewise, you can search GitHub for a whole range of subjects that you might be interested in. So there are thousands upon thousands of publicly available GitHub projects. If you just use the search bar, you could then find a tool that you might be interested in. For example, something else we built at Babram is FastQ Screen. We can then search for this in this repository or all of GitHub. If we click on this, we'll see FastQ Screen. We can then go to this and we have a new Git repository here, which we're free to clone and download as before. So I mentioned previously that GitHub is useful for making your documentation for projects available. I've just illustrated that here by adding to my GitHub repository a README file. So I've made my README this readme.md file, which is a markdown format file, which is just a very simple and convenient way of formatting text format files. Anyway, if you create one of these in the root directory of your repository, GitHub will automatically render this and make it visible on your home page. So this is a nice way to make documentation. As you can see here, I've managed to create different sorts of text formatting sizes. I've also embedded a link here, and I've also embedded images. So this is just using Markdown. If you're not familiar with Markdown, I would recommend just reading up about it. It's quite a simple sort of syntax to learn to be able to do this sort of thing. But once you've done that, just by creating simple text files, and so this is the actual underlying code that that creates that documentation that I've just shown, you can actually write using Markdown quite sophisticated documentation, and then it will appear on your homepage in GitHub. And you can get all the nice little things in your documentation. You can have hyperlinks to different sections, nice formatting, diagrams, and what have you. So yeah, so GitHub is also a nice way to manage your documentation simultaneously with your code base. So far I have been mentioning pretty much exclusively GitHub as a online remote place to store repositories, Git repositories. It's not the only provider in town. There is something called Bitbucket, which is at bitbucket.org, which is always worth looking at. And you will see many academic repositories stored here, and it's been around for many years. It's quite well. The documentation for it is very good as well, so it has lots of nice features too. Another sort of rising contender at the moment is GitLabs, which apparently is very good as well. GitHub is currently the leading online Git resource, but if you are interested, it's certainly worth looking at other alternatives. GitHub have provided a desktop app which you can use on Mac or on Windows machines, which allows you to run Git commands using a GUI. So by simply clicking buttons, you can push and pull and update repositories. Unfortunately, GitHub Desktop is not available currently on Linux. And though generally Linux users tend to be more fluent with the command line, for those using Linux wishing to perform Git using some kind of GUI, a popular tool to do this is Gitkraken. It's free and open source like the GitHub equivalent, and it's available on Linux as well as Windows and Mac. Anyway, I should be talking a little bit about GitHub Desktop, since we've been largely talking about GitHub in this talk. So you would download the software as you would for normal software and install it as per usual. You should also have Git pre-installed on your system before using GitHub Desktop. Once you have GitHub Desktop installed, you'll be asked to sign into your GitHub account. So just enter your details as you would to sign into the GitHub website. Once you have logged in, you can then clone your GitHub repository that you're interested in. So to do this, go to File, Clone Repository, and then choose the repository you want to clone. And in this case, I'll clone my project. So we clone this. And now we can see that we have this. We're currently working on my project. If you want to see the actual files, which will now have been downloaded to your system, you can just click Show in Finder or an equivalent on a Windows system. And now you will see the My Project folder, and here are the files. And I could edit these files with a text editor of my choice. So I shall use Sublime Text. I could open it up, and then I could edit the file, save it. And now that I have edited the file, I can see that there has been a change. We can see this difference between the version in the working directory and that in the repository. You can see that plus edit has been added. So this is similar to the git diff command that we saw earlier. All the change files will be listed here, and we can choose to add them, put them in the staging area by clicking this button here. And then if we wish to commit change to the repository, we would explain what we did. So we updated file A. So we could say updated file A to demo GitHub desktop. And then we could commit this to the master. So we've committed this to our master branch of our Git repository. And now what we do, if we wanted to push it to our remote repository, we would click push to origin. And it will take a few seconds to connect. And then it will make changes on the remote repository. And now it's all done. And now we can see that our change has been made. Here, file A updated, file A to demo GitHub desktop. So that's how we can change files locally using that nice GUI, and we can push them to our remote GitHub server. If we wanted to fetch files from the origin, which is the GitHub website, we would just click this button here. So there are more features to this software application, but I think I've illustrated the main point that you can essentially have a Git repository on your local system. You can then edit the files using the text editor of your choice, and then manage the Git commits and pushing and pulling process using this GitHub desktop process. And many people will find this a nice, easy way to manage their work. So for the remainder of the talk, I wanted to talk about some slightly more complex development workflows. Firstly, I'm going to talk about branches. These are ways you can bifurcate your code structure and work on different projects independently within the same GitHub repository. I'm also going to talk briefly about how you can work with teams or different people using GitHub. And then finally, I'm just going to introduce something called GitHub Actions for essentially testing your latest commits to GitHub repositories. So what do I mean by a branch? Well, so far we've only been working on one branch. So let me illustrate this idea here. By default, your starting branch when you start a new repository will be known as the master branch. And you can see a commit represented here. This is commit 1, it's your first commit to the Git repository. You then change your code a little bit and you create a second commit. And this is essentially what we call a branch. It's a series of chain of commits. And you can imagine this branch going on and on and on, commit after commit after commit. And that is fairly straightforward. But what you could choose to do is essentially bifurcate your code structure here. So that could be that you could carry on from commit 2 and create a commit 3, or you could start writing some new code using commit 2 as your starting point. So why would you want to do this? Well, it may be, for example, that you want to try out some new feature. You have an idea in mind of some new functionality for your code. It's going to take a little bit of development work and you're not quite sure maybe necessarily if it's going to work. So you want to try a new branch from your starting point of commit 2 and work on this. Now it may take some time to work on this new feature, and what you don't want this to do is interfere with the regular updating and adding patches to your software. So this way, by having a branch, you can then work on your regular maintenance work and basic development work while simultaneously working on this new feature. So as you imagine, we go along and then we have a new commit, so we now have a second commit of this new feature, and the latest version of your branch that you make available to other people perhaps, or use yourself, is commit 3. Then when you've satisfied yourself that this new feature works, you would merge your feature branch back into the master branch, and now we have one branch once more. Now that the two branches are merged, you can carry on to commit new versions as before, and these will be committed to the master branch. Although this may seem a little alien at first, using branches are par for the course for any mainstream development work. In fact, it is quite common for the master branch to only contain working and release versions of the software, while any development work takes place on a separate development branch. So as already mentioned, GitHub has a number of ways to allow collaboration between individuals. One way this can be achieved is to fork a repository. So for example, suppose I wanted to collaborate on the Bismarck project, which is a bisulfite aligner produced also at the Veblen Institute. So I could have a search for this project, and then I could go to the Bismarck homepage. And what I would do is, if I wanted to work on this, is I would fork the project into my own GitHub account. So to do this, I would click on the fork button on the project's homepage. And now the repository, a copy of the repository would be transferred into my account. I could then work on this as I would any other repository, as though it were my own, make the changes that I wanted to implement. And then when this is done, I could do something called a pull request. So when I make a pull request, like so, by clicking this button, this would allow me to merge a branch from my repository into a branch into the original owner's repository, who in this case is Felix Kruger, who owns Bismarck. He would then receive a message asking him whether he wanted to accept the changes I had implemented into his own repository. It's a little bit like when you merge branches in your own repository, except we're merging branches between my forked copy of Bismarck and the original copy of Bismarck. Obviously, the owner of the repository has the right to reject any changes. Alternatively, the owner of the repository may not want to implement the changes straight away, but may make some suggestions about what else needs doing. And when this is resolved and agreed, the pull request will be completed, and the branch from the forked repository will be merged into the relevant branch in the original repository. This is one way, using GitHub, that people can work on the same code base. I also wanted to discuss something in GitHub called actions. This is where essentially you can test a piece of code every time you commit it to your repository. Actions is found here, and if you click on it, you'll go to the actions page, and you create a new workflow by clicking the workflow button. So what happens when you do this? Well, it will create a YAML file. So if we go back to the home page of the repository, we will see this hidden folder GitHub and workflows. And if we go in here, we can see a YAML file I've made earlier. So if we click on this, we can see the workflow. And I don't want to go into this into too much detail, but if you're familiar with things like Singularity or Docker, you will see that these are a series of instructions to build from scratch a operating system, in this case Ubuntu. It will then check out the current repository, and it will perform a series of tests. In this case, it's just actually hello world, because this is a sort of example YAML file I've constructed. But what you could do is, for your repository, is you create the operating system you need. You then perform the git checkout, and then you can test your code by running commands which would run your command on the operating system, or you could do quite complicated things such as download test data sets and then run your code on this. And when you have set this up, what this means is every time you commit your code to the repository, this workflow will be carried out every time. And you will generate either a success, whether the workflow has been completed successfully, or it will let you know if there have been any errors generated. This way, you can simply and easily test your code every time you commit it, and you can do this automatically without having to manually test everything yourself. This is well worth setting up once, as once you have done it, it should save you a lot of time and effort in the future. So, to summarize, if you're writing even a small amount of code, and certainly pipelines or some sort of substantial project, you should definitely put your project under version control. Version control allows you to track all the changes you make to your software as your project progresses, and allows you, if necessary, to roll back to previous versions of your software. Of all the version control systems currently available, Git, a distributed version control system, is now by far the most widely used. In addition to being well structured and relatively easy to use, one key benefit of this piece of software is that it is free to use and therefore is available to anyone. You can run it via the command line, or if you prefer, there are more user-friendly alternatives available using a graphical user interface. Such tools are GitHub Desktop, which is available on Mac or Windows, or Git Kraken, which is available on Mac, Windows, and Linux operating systems. Git, being a distributed version control system, allows you to deposit your repository on an external server. A good and most commonly used such server is GitHub, and this makes an ideal place to deposit your repository and hence back it up. The website is well structured and has many features, such as the ability to produce nice and attractive documentation for your project. In addition to this, Git and GitHub repositories make an ideal way to collaborate and share code. So thank you for listening to my talk on Git and GitHub. I hope that was useful, and I hope if you've not used version control software, this will prompt you to go ahead and try it. Spending half a day or so to learn Git will probably be one of the most important and useful decisions you make in your coding career. So thank you for listening to my talk. I hope that was clear. I will be around to try and answer any questions you may have via Zoom, providing my internet connection holds out. So thank you for listening, and goodbye.